For centuries, pendulums have been used as time-keeping devices. The period of time it takes for a pendulum to swing back and forth is constant and depends on the properties of the pendulum. The period of time it takes for a pendulum to swing back and forth depends on the length of the pendulum. As we shorten the pendulum, the period of time for the pendulum to swing back and forth decreases. We could also say that the frequency of the pendulum has increased. The frequency is how many cycles the pendulum makes per second. You are looking at a computer simulation of a pendulum produced by the University of Colorado. In this simulation, the pendulum bob or weight is the big blue cylinder. We will assume that the string for the pendulum has no mass. You can use the stopwatch or the photo gate to measure the period of the pendulum. You can use a ruler to measure the length of the pendulum. You can adjust the length of the pendulum. You can adjust the mass of the pendulum. You can adjust the starting angle of the pendulum. For now, we will assume there is no friction and that the level of gravity is set to Earth. We can play with these features later. By using two pendulums, you can compare what happens to the period of the pendulum when you change length, mass, or angle. As you can see with the metronome, changing the length changes the period of the pendulum. As every child knows, on a swing, you go the fastest at the bottom, and at the top, you go very slowly. We can see this in our computer simulation if we display the velocity vector. At the bottom of the swing, the velocity vector is the greatest. This is known as the equilibrium position. At the extrema, or the top of the swings, the velocity vector goes to 0. We can understand what is happening using conservation of energy. This can be easier to see if we slow the video down. The pendulum has a constant amount of mechanical energy. At the extrema, all of the energy is gravitational potential energy and there's no kinetic energy. At the bottom, there is a minimum amount of potential energy and kinetic energy is at a maximum. We assume that no energy is converted into heat by friction. If there is friction, the mechanical energy in the system is gradually converted into heat.